We're on the tourist track on Ben Nevis, and it's a very frosty day at the end of a very frosty couple of weeks. So I don't know if you ever noticed these holes that develop in the path, and at the bottom of that hole there's a large stone, and up behind me there are a series of other large holes as well. There's one here, and even around these very large boulders you can see that it's sitting in a hole, and the smaller ones are actually falling down into the holes. So this is frost heave, and what's happening is that the water in the ground is freezing and it expands, and then when it melts again it contracts. So if you had repeated expansion and contraction, then you can open up holes. So as the freezing surface propagates downwards, the top gets frozen, so that then locks the top of the rock in place. As the freezing continues, then all the expansion is having to move material out from underneath, from below that frozen surface, so that you're compacting the ground underneath the rock. When it then melts, the ice contracts again into water, then the rock will fall down into that compacted space. So you might wonder why this is a path. They've already compacted the path. It should already be as dense as it can get. And actually what happens is that when you have granular materials, they lock up when the grains come in contact. And that jamming density, the critical jamming density, is a function of the strain rate. So when you're running over the path with these compactors, you're straining the ground very, very fast, and it will all jam up at a lower density, at a higher porosity than at slow strain rates. And this ice heave is happening over weeks, okay? It's taking weeks to get this, so it's a much lower strain rate, so you can actually end up compacting to a higher density, which means that you're removing space from the matrix, and the space that's being removed is basically the space that's sitting around these rocks. So this is a function of change of strain rate, and it's why it happens in paths and in built buildings, in built structures, much more than it happens with natural structures, because natural ones, they're all happening at the same strain rate. So this is ice heave happening. If you were to be in Russia, in the permafrost regions, this kind of ice heave can actually lower buildings by stories as they gradually sink into this not entirely consolidated matrix that they're built on.